Hi, this is Matt from Fuzzy Labs, and I'm here to tell you about our newest R&D project called MindGPT. As you might imagine from the name, it's all about large language models. Recently, Tom put out a video explaining the background and the plan for this project. In summary, what we want is to create a chatbot to which you can ask questions about mental health. To do this, we'll be using two different data sources. So we have the National Health Service mental health information on the one hand, and on the other hand we have data from Mind, which is a UK-based mental health charity. When you ask the chatbot a question, it should be able to not only understand the content of your question, but also synthesize an answer which can ideally compare and contrast the two different data sources and provide you with a summary. One of the remarkable things about large language models is this ability to be specialized towards a certain task. It means we can take a model which is generally good at lots of different things, provide it with domain-specific data, and create something that's really good at one thing, in our case, answering these questions about mental health. And even though it takes a lot of money and resources to train a large language model from scratch, if you're fine-tuning it for a certain task, it's actually not that expensive. And not only that, but it's feasible to create your own large language model from an open source base using entirely open source tools, and that's one of the things which we'll be demonstrating on this project. As we progress, we'll be chronicling our journey through blogs and videos. And let me tell you a little bit about how we're going to go about doing this. Firstly, we need to pick a base model, and we're going to use a model called Flan, which comes from Google. Flan is already fine-tuned for what's so-called instruction following, which means that it's already able to engage in a dialogue to act as a chatbot. Next, we need to get some data, so we'll be grabbing data from our two sources, from NHS Mental Health and from Mind, and do a little bit of cleaning up on that, prepare the data set so that it's suitable for use with a large language model. Next comes the exciting bit, where we're going to specialize the model. And there are two broad techniques for doing this. One technique is called in-context learning, and that's the simplest technique. Here you provide the model with a prompt telling it how you want it to behave. So you might say, given the following information, answer this question. The other technique is called fine-tuning, and that's where typically you would require a larger amount of data and more resources, but what you get as a result is a model which is far better specialized for what you're trying to do. We'll be exploring both techniques and sharing our own experiences and recommendations depending on your application. Large language models have given rise to a wide range of new tooling, and we'll be exploring some of that tooling too. For instance, we have vector databases, which are critical in this kind of application. And we also have things like LangChain. LangChain is actually a tool that joins up other tools to help you create applications around large language models. Another aspect that we'll be looking into is model deployment and monitoring of the models. Deploying large language models presents new challenges because they are large. We're talking models in the multiple gigabyte range. And then once they are deployed, you do have to monitor them because they're of such a nature where you don't know ahead of time exactly how they're going to behave in the wild. Monitoring allows you to have some measure of control and auditing, and it gives you the ability to update the model and retrain it in the future. And I want to say a little bit about why open source is so important on this project. For me, there are at least two reasons for this. Firstly, it enables us to create something which we can share with the community and generate some genuine collaboration. But secondly, and the deeper reason, is that especially given the current discourse around AI safety in large language models, we want to make sure that what we're creating here, anybody can look in and understand what it's doing, how it's doing it, why it's giving a certain answer. We believe that openness is pivotal to creating safe, auditable, generative AI. And finally, I'd just like to invite you all to follow along with our progress. We'll be publishing blogs, videos, and sharing the code on GitHub. And we'd love to get your feedback and input as we build MindGPT. That's all for now, and I look forward to hearing what you think.